This next song is really kind of my favorite song. All right, Warriors, good to see y'all. Hope y'all are well. Hope you're having a good evening, and we will get right down to it with the map check up on the screen. Taking a look at what we have going on. That little red arrow tells us we're here today on the beautiful topic of regression. On Thursday, we're going to do some We Drive, and in between, posted today, available today on Canvas assignments is the regression assignment that'll be due this Sunday, no later than 11:59. And we can go over where that is if you're having trouble finding that. Had an issue with my other section, and I fixed it with you also. You should be able to see it, pretty straightforward. And after tonight, you'll be able to rock that thing out. In fact, I would recommend that if you have time tonight, you go ahead and knock it out, but that's up to you. Looking ahead to next week, we're going to spend all next week prepping like we normally do for the final. The final will be comprehensive, so we're going to talk about what will be on it, what to expect. We're going to go back to descriptive statistics, spend some time on that, and then go back through confidence intervals, sampling, and then what we just did, hypothesis testing. So we'll spend next week doing that. Next Friday, so not this Friday, but next Friday, the 8th, couple things will happen. Number one is I'll post your classroom interaction and participation assessments. And so that way you'll know all the points that you've got up to this point. The only thing due out will be the final. And at the same time, I'll offer reading day repetitions. I've decided on these following hours. So 30-minute shot is what you can sign up for if you want to. So a couple things there. The Warriors in the past have said, hey, are you available on reading day? I'd like a little bit of last minute love on reading day just to go over a few things. And so as a tradition, I've done that and offered those times or offered time on reading day. You don't have to do it. I'm not keeping a black book on who does it and who doesn't do it, that kind of stuff. But it'll be your time, you and me, one-on-one to talk about anything you want to talk about. If you're interested in that, you just email me, first come, first serve. You can say, hey, I want 2:30 to 3. And if it's not taken, it's all you. We'll do it on Zoom. So that'll be on Friday, the 8th. And then the exam, quite honestly, I've given thought about it, but not specifically in terms of when it'll be. I know we have a time slot, so I'm very, very mindful of that. I'm also mindful of the stress that goes with taking an online exam. And so more to follow on how that'll be. At a minimum, I'll give you as much time as I gave last time, but I owe you more specifics on structure, what to expect, and all those kind of things. And that will come sooner than later. So that's our map check for now. At this point, I'll pause and see if you have any questions, big or small, about that. Okay, looks good. Let me just do this thing right here. All right, cool. This is sort of our agenda for tonight. We're already recording. What I want to do to modify this just a tiny little bit, I want to start with a couple notes on p-value, and then we'll get into regression. And then if we have time at the end, which I doubt we'll have time to do it, but if we do, then I'll bring up a problem from Pearson and go through it because it gets after p-value in two different ways. Regardless, if I'm not able to get to that problem, I have the step-by-step version of it for you. So I'll post that on Canvas so that you can have that and do what you want to with that. So I want to begin with a couple points on p-value, really as a review. This isn't any new material here. I had a couple questions, actually not from this section, but I felt it valuable to just review p-value for a second. First of all, p-value is a probability value. It's a specific probability value for a certain t-stat and really a certain hypothesis happening. Okay. So it's not that different from our normal definition of probability, but the main thing is connected to some sort of test statistic right off the bat. And so that leads us to the next question, and we can divide this in half. Um, and let's just put T stat over here, and let's put Z stat. So the topic of discussion is, how do we determine p value? Well, that depends. It depends on what our test statistic is. So if our test statistic is a T stat, we're going to go about it one way. If it's a Z stat, we're going to go about it another way. And of course, as some review, we know that we do a Z statistic when we're in two situations of our possible three. The first is if we're dealing with a population proportion. We're going to roll with Z statistic and Z distribution every time. The second is if we're dealing with a population mean and we know the sigma. That when we would roll with the Z statistic. Over here, we would roll with a T statistic when we're dealing with a mean, population mean, but we do not know the sigma. Okay, so the first step on both, all right, really step 0 is, are we dealing with a T statistic or a Z statistic? All right, that's almost the strategic step. So that's kind of step 0. And then step number 1 beyond that towards computing the p-value is the same in both instances. And that is determine the respective test statistic. So determine the value of the z-stat and determine the value of the t-stat. And when I say and, it really is either or. I mean, you're over here, and if you're here, you're going this way. And if you're over here, you're going this way. So let me just talk about, let's assume that we're over here. So we determine that t-stat value, and then we have to figure out, is it a one-tailed or is it a two-tailed test? And if it's a one-tailed test, which tail are we dealing with? Okay, so we know so I'm just going to put our questions over here. Is it a two-tailed? Is it a left-tailed? Or is it a right-tailed? Okay, and the function that we use in Excel to determine the p-value is different for each one of these. If we're doing a two-tailed, that function is going to be t.dist, and I'll get to the rest in a second. If we're doing, I'm sorry, dot 2t, okay? If we're doing a left-tailed, one-tailed t-test, it's going to be t.dist with nothing on the end. There is no .lt. It just defaults to that. And then if we're doing a right-tailed, we're going to have tdist.rt. Okay, so that's that second step, is we've got to answer what type of tailed test do we have, because that's going to make a difference on the function that we use. In every case, regardless of the function that we use, we're going to have to enter some values here. And the first value it's going to ask us for is, Excel is going to say X. And it's very, very important that we know that that X, that the equation, either one of these is asking for, is really the value of the t-stat. Okay, so that's the first thing. I'm just going to write whatever our t-stat is there. But it don't get fooled. Don't put just something else, because it's not very descriptive. I don't know why it is that way, but that's Excel. Sometimes it's kind of finicky. I also got report back when I put a negative number in this function, in any of these functions, it gave me an error. And I got word back from another warrior that she got it to work with a negative number. I don't know if that's a difference in our versions of Excel. I don't know anything about that. But at the end of the day, I would think it would work whether you put a negative number or a positive number in here because the distribution is symmetrical. So um, I'm not too concerned about this. If you put a negative number here and you get an error, put a positive number and it should work out. The second piece of info that Excel is going to ask you for is degrees of freedom. And we remember that degrees of freedom is n minus 1. So I'm just going to put df. It actually spells it out. And then the last thing it's going to ask you for is a true or false. You always want to put true here. And I don't know if I covered that the other day. Okay, so bottom line, select one of these functions. Once you do and put that front parentheses there, Excel is going to prompt you for these. It's not very good. It puts X down in here. Just remember it's asking for that T-stat. And then out of that, you're going to get the p-value. Okay? And the p-value is the p-value. You don't need to multiply it or anything down here because you already had, whether it was one or two-tailed, embedded in selecting this function. Okay? So how you determine p-value, if you have a t-stat situation, you determine that t-stat, you select the appropriate function based on the tailing of the test. I don't even know if that's a term, but it is now. And then you put the right info in there and you should be good to hook. All right, let's go back over here. So let's say you're not in this situation and you're over here. Same thing, you start out, determine that z-stat. Now here you're going to take a different route. You've really got two choices. And we'll determine tailing in a second. I guess I'll put A. So choice number A is you could take that Z stat and go to the Z table and convert that Z stat into a probability that's going to have 4 digits. All right. And we should know how to do that. We go down to the left side of the Z table and then we go over how many columns we need to, and then we get this 4-digit number. The other way is to use this function in Excel, norm.s.dist. All we've got to do there is enter the Z stat as it is, positive or negative. We want to keep it positive or negative. And then we're going to enter true. And that will give us the same number here. Here's the trick though. We have got to know, same kind of thing as over here. We've got to know, are we dealing with a two-tailed test, a right-tailed test, or a left-tailed test? All right. Let's talk about the easiest one first, which is the left-tailed test. If we're dealing with a left-tailed test, whatever this number here is, so let's just say this number is, we'll make it nice and even, 4000. Okay. So if we're doing a left-tailed test, we determine our z-stat, we go to the z table, it turns out that's the probability for that respective z-stat, or we do this function here and we get 0.400 and it's a left-tailed test, then that is the p-value and we're done. Okay. Obviously it's a big old p-value and we're going to reject or fail to reject the null hypothesis because the p-value is not lower than any kind of level of significance we could have. But let's talk about these other situations that are a little more problematic. Let's say we're in the right tail and we get this value here. Or wherever we're in the right tail and we get something like this, actually, we're not going to get something like that on the right tail. We would get something more like Let's just say this 0.6. Okay. And the reason I say we're not going to get something like this on the left tail is because it's less than 0.5. Um, so we'll probably get something more like this because remember 0.5 is the left half or the right half of the distribution. A z-score 0.5 is smack dab right there in the middle. So let's say we have a right-tailed test. We go to the table, we get a 0.6. We have to do a 1 minus. We have to do that. That's going to give us a 0.4. And so for the right-tailed test, this would be our p-value once we've done that 1 minus. Anytime you're on the right tail, you have to do a 1 minus to get your p-value. Finally, either way you slice it on your two-tailed, let's say that you're not going to get this on a two-tailed. You might get this on a two-tailed. All right. When you take your ZSAT, you go to the table. Let's say you get a 0.4. Whatever you get is your initial probability. You have to multiply by 2 in order to get the two-tail. Okay. That's a pretty whopping p-value. All right. But the bottom line is this is what makes the two-tailed test the two-tailed test. Because on the two-tailed test, somehow you're finding one of these and you're multiplying by 2. And the one that you find first is going to be dictated by your z-stat. Okay. So if your z-stat is negative, you're going to find this one first. If your z-stat is positive, you're going to find this one first. But either way, on a two-tail, it doesn't matter. You're still going to multiply that times 2. All right. Now, here's where it gets really confusing. If you're on a two-tailed test and you have a positive z-stat, meaning you're over here, you've got to do a 1 minus first and then multiply that number by 2. All right. So anytime you're on the right tail at all, and you have a z-stat that you're converting into an initial p-value, you have to do a 1 minus. Okay. And if you have a two-tailed test, then you do a 1 minus, and then you multiply that number by 2. All right. So hopefully I didn't cause any more confusion. I'll pause here and see if there's any questions on what I've just covered. All right. Well, you've got that video. Again, I don't like saying, okay, you can watch the video later if you don't get it. You always have me if you don't get it, if you don't feel comfortable asking a question or things like that um, in this situation. So with that little thing about p-value and hopefully determining p-value on Pearson wasn't difficult for anyone, we will go on to this thing called regression. So I need to tell a quick little story. First, there was a time way back before Instagram and pandemic and all that kind of stuff when people lived in caves. And they were generally pretty happy. They kept to themselves. They lived in caves. But every now and then one of the kids would ask, hey, Mom, why don't we go outside? And invariably the response was the same, which was, we can't go outside because the beast lives outside. And we know about the beast from the ancient hieroglyphs that are very, very dangerous. And if we even talk about the beast, they go outside, the beast will emerge and rain down apocalypse on everything that we know and destroy the world as we know it. So we're better off to just stay in the cave. And this worked for most people. They avoided this thing called the beast, which was also named as regression. because they were scared. But there was one tribe that refused to be scared. And that tribe was known as, you guessed it, the D3M tribe. And the D3M tribe said, wait a minute, you're going to tell me that we're scared of this little thing called regression? Well, we have this powerful thing called Excel, and we can do all sorts of fancy functions. And beyond Excel, we have our Batman-like brain, and we can figure stuff out. So rather than sitting here in the cave, we're not going to fear the Reaper. We're going to come out of the cave, and we're going to rock this thing out like Judas Priest. Because this thing, regression, it sounds like a beast. You say it's a beast, but it can't be that bad. And the truth is, it's not that bad. It's just like little bunny. You just got to pet the bunny. I mean, if you pet the bunny, what's the worst thing that can happen? The bunny tries to bite you? I mean, I don't know. I guess that could be bad. Here's my point. There are folks up and down the street, all over the place. When you say regression, they run and hide. If you were one of those folks previously, you will not be that way tonight. In fact, you will be just the opposite, the D3M warrior that you are, and you will grab those folks and say, do not be afraid. I will show you the light, because it really, really is not bad. Now, if we try to do this by hand, it's not impossible, but it starts to get to be kind of a headache. So we're not going to do it that way. We're going to do it the easy way. And after tonight, you'll be going, I really don't know what the big deal is. And if you say that, then we have been successful. So with that, let's go into a little overview about what regression is and what it means and why it's useful. I really think regression is cool because we can predict the future. We can do a lot of things with it. So that really is the primary purpose of regression, is we want to do some prediction about the future. We can call the shots. We can be the shot caller. But first things first, we have to kind of tread lightly. Being the scientists that we are, we're not just going to throw caution to the winds and be cavalier and irresponsible. So the first thing we need to do is, and oh, by the way, with this, we're looking for the relationship between two variables. Okay, we're going to predict the future of one of these variables based on the other one. But to do that, we first have to validate that there is indeed a relationship that we can base some assumptions on. See, there's a word, and now you're going, oh, I could do that. I'm in the habit of making assumptions. I just went through this way of the warrior thing, and you're damn right. That's exactly what we're going to do. So just like anything else, we're going to look at the data first. So let's look at some examples. And really what we're looking for to see if there is a trend. Now, when I talk about trend, I don't mean stuff like, hey, bell bottoms are coming back or retro is in. I'm not talking about that kind of trend. I'm talking about a quantifiable trend, which is actually much more simple than it sounds. Let's check it out. Here we have our X and Y axis. Let's say we have a variable A and we have a variable B. And let's suppose that, a simple example, A is the temperature. So as we move this way, temperatures are getting greater and greater. That means it's getting hotter. Okay. And we have a variable here. Let's say this is the sale of ice cream. So here we sell 40 cartons. Here we sell 400 cartons. So we have variable A, which is the weather. We have variable B, which is the sale of ice cream. And we have some data. Of course, life wouldn't be complete unless we had some data. And we noticed as we plot the data it looks like this. Okay. And this is a positive upward trend. As the weather increases, the sale of ice cream increases. And we go, huh, that's pretty cool. Well, what if I ask you, hey, predict this time, or if the weather goes up to this temperature, how much ice cream could we sell? Well, we could figure that out through a regression model. Pretty cool, I think. Let's look at another scenario. We might have weather again. I should have called it W. I don't know why I didn't. Anyway, and let's say we have a different variable. Let's call it C. And let's suppose that A is still temperature going up and up and up. And C is hot drinks, the sale of hot drinks, coffee, maybe. And we have something going on when we pull the data out that goes like this. So the hotter it gets, the less hot coffee I sell. We probably still sell a lot of drinks with like 7 names in it, like cold brew, frappuccino, Rohrbach, Leftridge, Grove, special. Anyway. All right. And so I say, hey, predict this value out here. We can do that through regression. All right. There's still a couple things, a couple terms we need to establish before we start rocking out with the numbers. One is that we identify what's independent and what's dependent. So between these two variables, we need to figure out, number one, which is the independent variable and which one is dependent. And here's what I mean. It sounds much more complicated than it is. One is dependent on the other one, and that dependent one goes on our y-axis. All right. So in our simple example, weather, Mother Nature's not dependent on anybody. Mother Nature wakes up in the morning, is like, I'm going to do what I'm going to do. If I want to rain today, by God, I'm going to do it. If I want to have a tornado today, by God, I'm going to do it. I don't care what anybody thinks or anybody says. I am flipping Mother Nature. I'm independent. And that is the best example I can give of that. I can go home now and go to sleep. Wait, I am home. Okay. So Mother Nature's like, I'm going to do what I'm going to do. Now, ice cream, kind of dependent on what Mother Nature does. Hot coffee, kind of dependent on what Mother Nature does. So when we set up our regression model, we say this is the X variable and this is the Y variable. Okay, so if we're given a narrative, we want to look for things that can help us identify the independent variable between the two and the dependent one. Okay. And again, the dependent one is dependent because it's dependent on what the independent one does. All right. So that's a distinction there. What else? But these are trends. Okay. Now, here's what's not a trend. Something like this, where we have two variables and we have kind of just all over the place. That's not a trend. All right. At least not one we're going to examine with regression. We have other models for examining this. We're not going to cover them in this class, actually. So this, for the all intensive purposes, as our definition of trends, does not meet the definition. We need something like that looks a lot more like this, which is an upward trend or a downward trend. Okay. And with this relationship here on the left, we would say it looks like they have a positive relationship. Here, this looks like they have a negative relationship. As one gets big, the other one gets small. Okay. As temperature goes down, hot coffee goes up. All right. Now, let's bridge between this into some numbers. And to do that, Let me get some space for my tattoo.
I have a question.
Yep.
So do the trends have to be straight lines, or can it start off like going horizontal, then curve up to vertical? Could that be a trend, or does it have to be straight?
It doesn't have to be perfectly straight. I mean, we probably have some variation in here. So what's more realistic is, and I'm just going to redraw both, and hopefully this answers your question. Um, Something like this or this, you know, because the bottom line is if we can draw a line through that. And because we can draw that line through that, we can do these projections here. Now if what you're talking about, if it's like this and then we kind of go like that, I don't know if I'd feel as comfortable with this.
Okay,
It kind of depends, but I'll make it pretty clear cut for you so that it's, I mean, I'll outline a lot of those assumptions for you.
gotcha. Thank you.
Yep. Okay. So tattoo time. Correlation is not causation. Put that under your pillow. Correlation is not causation. Say it 5 times fast. Not right now, maybe later. What do I mean? Well, the weather going up is correlated with ice cream sales in a positive way, meaning as temperatures increase, so do ice cream sales. But that is the correlation piece. But to say that hot weather going up caused ice cream sales to go up, there's still an inch there that I'm never going to be able to breach that gap. I can't really say that. Okay. It's kind of like this here. As weather temperatures go up, according to this data, hot coffee sales go down. Did the weather increasing in temperature cause people to drink less coffee? I can't really say that. Okay. And you will hear people confuse this stuff all the time. Let me give you an extreme example. I hope none of you are Nicolas Cage fans. I don't have a problem with Nick Cage. He's kind of gone off the anyway. So somewhere on the internet, this is a terrible thing. Well, it's such a terrible example. I shouldn't use it. But somewhere on the internet, there's one of these graphs. It's almost a meme that says, here are the number of Nick Cage movies, and they've increased over time. And here's the amount of suicides in America, and those have increased over time. Well, the amount of Nick Cage movies increasing probably had nothing to do but with causing the amount of suicides in America. All right. But that's the whole point of this ridiculous diagram, is that just because two things are increasing at the same time, or just because they have a negative correlation where one goes up and the other one goes down, does not mean that they cause each other. All right. So if you want to disrupt somebody's day, which half of this course is about, wait until you hear somebody say that and make that confusion. And then you throw that D3M sticker down and say, hey, hang on a second. You really can't say that. It's correlated, but it's not caused. And that'll probably kind of derail them, and that'll be the end of that. Be careful about who you do that with, obviously. Okay, so this is a big thing. All right. Now, here's the other thing. You'll hear people throw around this term correlation all the time. And we don't want to do that anymore. Okay. What we want to do is stick to the scientific definition. All right. And if we don't have the data at hand, if we kind of have a drawing, like here, we don't have data, all right? So, but if we really want to be professional, and again, this is all about becoming professional, we could say, you know, this looks like the two are positively correlated. But if we really want to rock that out, let's get hold of the data and we can quantify that. Let's talk about how, and then we'll go to Excel. We have our friend R, and R is a correlation coefficient. It's not R squared. Somebody today asked me earlier about R squared. There is such a thing as R squared. I'm not a fan of R squared because I can't put R squared into a practical definition, but I can with R, and so I will. R ranges from greater than or less than, or excuse me, less than or equal to 1, greater than or equal to -1. So if I have the data behind this, I can measure the correlation and I can describe the nature of that correlation in these terms to where I would bet that more people understand that than not. So here's what I'm talking about. I don't have to kind of be a poser and go, yeah, this looks like it's negatively correlated, weather and hot coffee. If I have the data, I can figure out what R is. R over here is probably something like -0.86. That's not a slope. That's not anything. It's an R value. That means, whoa, that's really a lot closer than not to -1. Okay, which means that as one goes up, the other one goes down. And so based on that, I can predict what that X is with a lot of certainty. I can make some good, solid assumptions there. Let's look at this graph. Here, if let's say I have the data, I compute R, and R is like positive 0.95. That's a really strong, that conveys a very strong positive correlation between weather and ice cream sales. So no more do I have to pose and throw around this term correlation and not really know what it means. Now I can quantify it. Okay. And again, like Deming said, with, when you don't have data, potentially you're just another person with an opinion. But now I don't have to be that person. I can be an informed person and describe the nature of that correlation. Okay. So that's the first thing that I want to do is I want to define what the nature of the correlation is. And then I can start using regression to predict those values out there that I want to. Now, before we move on, one final thing. If I got on either one of these things an R that's kind of mediocre, non-committal, as I like to say, of like 0.35, that's a lot closer to the middle, which is 0. Okay. If I have an R coefficient of 0, that means there is no kind of relationship between these two variables. That graph would just be all over the place. Okay. So if I have a value that's closer to the 0 than one of these ends, I really shouldn't do anything in terms of regression with that data. I should just kind of leave it be and kind of go, we really shouldn't make any predictions based off of those two things. We might want to take one of those variables and find another variable that it has a stronger relationship with, and then predict off of that. Okay. Questions so far before we go into some numbers? Good? Excited? Somewhere in between? Somewhere in between these values? All right. Let's go to Excel. All right. You can see what's on my mind: hot dogs and onion rings. All right. So somewhere in our narrative, we've made the decision. First things first, we want to decide what we think is dependent on the other thing. We have our two variables, hot dogs and onion rings. And just in this model, in our narrative, somewhere in there, we've decided that onion ring sales depend on hot dog sales. Maybe we could say, well, it's a side dish. And so if people buy one, they're probably going to make a decision on a hot dog first, hot dog or hamburger, and then make a decision on onion rings or fries, that kind of thing. Okay. So first things first, we want to describe the nature of the relationship between these two. Probably step zero, just to make things clean. Of course, we got to know what we're doing here is to sort these lowest to highest by the dependent variable or the independent variable. So we first labeled up here X and Y. We next want to sort. Okay. And you see how that 250 is down here? Well, we kind of want it up there and that 155 to go with it. So we could do all this manually, or we could go to custom sort. I always use custom sort because I don't trust Excel entirely. Don't let it hear that. And I'm going to go here to sort by hot dogs. And I have that A to Z, which means smallest to largest. And it's going to tell me smallest to largest. And bam, that's fixed. Okay. I don't have to do that, but it makes things kind of clean. The next thing I want to do is I want to describe define that correlation value, R, and see where it falls between 1 and -1. So I'm going to type in coral right there, and I'm going to give this. All right, it's tiny. I know you may not be able to see it at home, but it's going to ask me for array 1 and array 2. This is the only time when it doesn't matter which array I put in there first. I'm just going to put in the X value, but I could put the Y's in first. It doesn't matter. So I'm just going to highlight one array like that. I'm going to put my comma, and then I'm going to highlight my other array. Boom. And I'm going to see what this R is, 0.983. That's really close to 1. So that tells me that there is a very strong positive correlation between these two variables. And based on that, I could probably go ahead and do some regression, do some prediction. Now let's go ahead and plot these two. I'm just going to go to insert and grab my scatter plot. I'm not going to do the connected one. I'm just going to do this one over here. Come on over here. All right. And I've got to remember that hot dogs is my x-axis. Of course, I denoted that up there. That helps remember that hot dogs is my independent variable. And then onion rings are my dependent variable. And like we talked about earlier, this doesn't have to be straight. If I connected these, it wouldn't. But I could draw a dotted line through them, and I would have an upward progression. Okay, cool. Now, let me do this. Let me do this right here. Okay, so the next thing we're going to do is we're going to establish what the slope of that line is, that imaginary line that runs through all those points. So let's start with some familiar terms. We have hot dogs, which is our independent variable, and we're trying to figure out how many onion rings at any given time. Based on a value of hot dogs, how many onion rings would we have? All right. So I've seen this written, I don't know, probably at least 3 ways. You can put mx here plus b, as long as you know what m is and b is. I personally don't care if you call b Jenna, you call m Alexa. It doesn't matter, as long as you know that this value right here is our slope. And this value here is the intercept. Okay, to be specific, it's the y-intercept. Excuse me. So, not to insult anybody's intelligence, I'm never down with that. When we have our imaginary line, first the intercept is the easy one. That's where that line is going to intercept the y-axis. And the slope is the nature of change between, as we increase x, how how quick or slow, steep, I guess is the best term, does y increase. Okay. So for example, if this value was 2, that would mean that for every 1 unit that we increase x, that y increases by 2. All right. So you don't have to be an expert on all this stuff, but you just kind of do need to have some general knowledge of what we're doing. And what I'm going to do is just copy this equation and take it over to our Excel. So we have it nice and handy when we do some work over there. All right. Let's see if I can find it. Here we go. Kind of big. Doesn't need to be so big. Ah, come on now. All right. Okay. So you're probably going, Dr. Shatzkin, I thought you said this was going to be like really simple. Well, it is. All right. Don't sweat the technique. It's a lot simpler than it looks. So let's just work this left to right. So what we're going to do is we're going to figure out what this equation is for the purpose of figuring out that y. And just to put things into context, let's say that now that we've established there's a positive relationship between hot dogs and onion rings, well, we know we have an event coming up where we're going to sell 700 hot dogs. We have 700 people registered for the event, or we figure demand is going to be 700 or something. We know we have an idea that we're going to sell 700. So the question is, how many onion rings should we have on hand? Okay, that we think we're going to sell. So to figure out what that number is, that yellow number is going to be our Y. That blue number is 700. We got to figure out what our slope is and our intercept is. And that's where Excel really hooks us up with some simple ways of doing this. Now, all of you are smart people. Some of you probably already know other ways of doing this. There's at least no pun intended. There's at least 2 other ways of doing this. I think this is the simplest way. If you want to do one of those other ways, I will say the same thing that I always say to you. Rock on with your bad self. Just please know what you're doing. All right. So I think this is the easiest way. I just write slope here, and then I'm going to figure out what slope is. I'm going to tell Excel, hey, I want you to tell me what the slope is. You got to do this right. 2 things. Number 1, I've got to put the Y values in here first. Cannot stress that enough. So I go over here, my Y's, and I'm going to grab my Y's only. Okay. It's not like before with correlation. I could just grab any old array. I have to put the Y's in first. Excel all of a sudden becomes finicky in that regard. The second thing, and of course, I'm going to put my X's in last. Notice I don't include that 700. See this? Okay. My 700, because my 700 doesn't have a partner yet. Okay. They're not married yet. If I put my 700 in there, it's just going to gank up everything. So I have nice, clean, what I call happy marriages. Okay. Everybody's married up here. 200 has a partner of 120, 250, 155, etc. Everybody's happily married. That's 700. They're like on, I don't know, bachelorette party or whatever anyway. All right. So there's got my slope. That 0.938 looks a lot like this 0.983, but that's really just coincidence. There's no, this is an apple, this is an orange. They're 2 different things, so don't get those confused. Again, slope means every time I increase a value of 1 down here, I almost get a 1-for-1 increase in the Y value. Now, intercept, same. It's just as straightforward. So I'm going to type intercept. Same. I'm going to grab my Y's first. I got to do that. And then I'm going to grab my corresponding X's. Okay. So I have a negative number, and a negative number is nothing to get like worked up about or upset. It's no indication that anything is wrong. Actually, if we just look at this, if we drew this line back and kept on going, it would intersect the y-axis somewhere down here below the x-axis, which would be a negative number. So that all makes sense. At this point, we're about on the 5-yard line, okay, ready to fall into the end zone. All right. So we're going to do the final process. So we have a value for our slope. We have a value for x, that's that 700. And we have a value for b, our y-intercept, that's that negative 75. Now, all we got to do is do the computation. We can do that on a calculator, or we can do it right here in Excel. I'm going to do it right here in Excel. I'm just going to do it nice and slow. So first things first, I'm going to grab my slope. I'm just going to work left to right. As long as you don't violate PEMDAS, you can do it any way you want to. I'm just going to work it left to right in concert with our equation down here. So I'm going to grab my slope first. Okay. I'm going to multiply by that x, which I have right over here. And then I'm going to add my intercept. Now, you might say, well, why don't I just go ahead and subtract it? Well, if you subtract a negative number, you're going to end up adding a number. So I love all y'all. You're all smart people. Just don't overthink it. Don't overcomplicate it. I just add it every time. And that way, if it's negative, it just works itself out. Bam. So there's my answer. 581, probably 582 hot dogs onion rings is what I'll have on hand. Because I can't see myself giving Ryan would get pretty mad if I gave him 0.76 of an onion ring. He'd be like, dude, you've been eating my onion rings or what? All right. So that's how I figure that out. Any questions so far? Good?
Yeah, I got a question. Can you just click on the R so I can write down the formula? I just didn't write the Excel formula down.
Yeah. So I don't know, Tim, if I could get it any bigger. I can't. Can you see it?
Yeah, I can see it if I make it full screen.
Okay.
Yeah.
So I just want to do coral, and then it doesn't matter which array I grab first.
Okay.
Okay. But they've got to be equal just like everything else.
All right.
All right. So if I was asked the question, based on these numbers, what type of relationship do we have? I can define the correlation. These are positively correlated. And based on that strong correlation, I can do a regression and answer the next question. Okay, so if I'm going to sell 700 hot dogs, how many onion rings do I need to have on hand? Let's look at another example. Hot dogs and spinach salad. Yeah, right. Now, intuitively, I bet you have the same reaction that me and my kids do. As an inside joke, every day I say to my kids, they go, what are we having for dinner? And I go, spinach salad. By now, they kind of don't listen to me anymore, but that's nothing new. But intuitively, I think we'd all look at this picture and go, dude, are you kidding me? There's no way these two things are going to go together. Well, again, the whole point of this class is to complement intuition with some mad skills in the form of science. So first things first, we're just going to get our house in order and get these things sorted. Not that it's required, but just to make things nice and clean. Again, we've identified that hot dogs is our independent variable. All right, so again, it's X. We're going to sort by hot dogs, smallest to largest. Get that nice and cleaned up. And what the heck, we could just graph these things at the same time. And lo and behold, it looks like as hot dogs go up, the amount of spinach salads would go down. Okay, so let's just confirm the shot group, as we used to say in a former life, by first figuring out what that correlation coefficient is. I'm just going to give myself a little bit more room. Okay, so again, coral, doesn't matter what array I grab first. Grab my second array and the envelope, please. Negative 0.94. That's a very strong negative correlation. So based on that, I could probably rock out some regression. And here we have an added benefit of regression. So let's say that, I'm in charge of catering for this big event. I know I'm going to sell 700 hot dogs. I have one vendor that wants to position spinach salad next to those hot dogs, like at the concessions booth. And I have another vendor that wants to position onion rings next to it. And let's say both of these folks are my friends. And so there's some emotion involved. Well, now I can find out which would sell more. And of course, you might say, well, spinach salad might cost more or less. Let's just say they cost the same. Okay, so let's take that out. So same process. I want to figure out my slope and my intercept. Okay, and I don't want to give anybody, I'm sorry for jumping around. I just want to bring my equation over here just so you all can see it again. Okay, so my same process. Again, always load the Y's in first. Boom. And then I'm going to load in my X's. Boom. Nice, neat, even. What's the problem with the formula? Did something wrong. Was showcasing or something. If at first you don't succeed, try again. Okay. Negative 0.91. Well, it's negative, and because this is going like that, I would expect it to be negative. Again, this slope, just because I have a negative correlation coefficient, I have a negative slope, that makes sense, but again, they're still different things. And then intercept. Well, let's just think about this. If I trace this line backwards, I didn't really mean to do that, but that line is going to intersect the y-axis higher than that 700. How much higher? I don't know, but that number should probably be higher than 700. So let's check it out. Intercept. I load in my y's first and my x's second. So my intercept is more than 700, as I suspected it should be. It's 763. Okay, cool. I still haven't answered the question of how many spinach salads I would sell if I sold 700 hot dogs based on this regression model. So to do that, I'm going to do just what I did before. I'm going to follow left to right my equation for my line. I have M, that's my slope. I have B, my y-intercept. My X is going to be 700. So just slow and low, that is the tempo. I'm going to put all that into Excel. So I'm going to grab my slope first. Boom. I'm going to multiply that by my X 700. Boom. I'm going to add my intercept. Boom. 125 spinach salads. So not a big surprise there, but again, we complement emotion, we complement intuition with science and logic. And I tell my friends, hey man, I love you, but check it out. I'm only going to sell 125 spinach salads if I stock them next to hot dogs, but I will sell 581 plus onion rings. So sorry, spinach salad, dude. It's not going to be your day. So I can make a product selection. I can compare two different products and make a product selection based off of that. Okay. If that's something I want to do. So that's another purpose of regression. Let's talk about a couple more things we can do. One thing I didn't talk about early on was we talked about two variables. Okay, so what I'm going to do is I'm going to copy this one and use it to talk about one more thing, which is time. Now, let's suppose that, I'll just call this time. And let's forget about onion rings for a second. Okay, we're going to get rid of this because it's null and void. And we'll just clear these out. We're going to end up doing them again. Let's take this. And I'm just starting up a new situation here. And let's say that we have time. So this is by month. And we're working down at the baseball park. And so this is something like October. No, it's not that. Let's say this is April. Let's go backwards. And this doesn't really make sense because we don't play. And I got it. You know, we don't play baseball in January, but we have events at the baseball park. We'll just say that, not confine it to baseball. And so what we want to do, let's give ourselves some space here, is we want to determine, we have a big event coming up in July. Okay. And we want to forecast, predict how many hot dogs we're going to sell in July. Well, first thing we want to do is, like we did before, we want to figure out the correlation. Okay. But the problem is, if we put anything to do with these values here into Excel, it's not going to like that. So let's just make this a little bit wider. What I'm going to do is I'm going to turn these into numbers. And then once I do that, game on. All right. But I got to know what I'm doing. Let me get this a little bit smaller. So first things first, time in this manner is the independent variable. It's like that phrase, time waits for no man. So time's going to do what it's going to do. All right. So time is our X variable. Of course, all I'm going to here, it's the same variable. I'm just going to rewrite it. And hot dogs is our dependent variable. In this case, we're assuming that the month of the year, there's a dependency on the amount of hot dogs sold on the month of the year. Okay. So I could just as soon put X here too, but I don't want you to think I have two independent variables. I only have one. It's the same one. I'm just writing it a different way. And the way I'm going to write it instead of this month is I'm going to go here to my first time period, and I'm going to call that 1. And this is going to be 2, this is going to be 3, and this is going to be 4. Okay? Now, for simplicity's sake, I could get rid of these. I'm just going to gray them out so that you can continue to see what we're doing and remember that all we did was rewrite these. But I could just delete this right here. Okay? Now, first things first, what's the correlation between, I have 4 happy marriages. So just like I did before, I got to spell it to do it. I'm going to grab this array and this array. 0.98, pretty high, positive correlation. Now check it out. When I have this kind of thing going on the x-axis, 1, 2, 3, 4, what I call the Gloria Estefan, there's an old song anyway, at the risk of sounding a boomer, I'll stop right there. You just grab one set, go to insert, and do our scatter plot, and bam. Okay, this is kind of not the way I want it to be. And I can fix this real quick by just not allowing it to do 0.5s. Units. I think Would that do it? Yeah. Good enough for now. Now, on a side note, I would never brief anybody on these results this way. I would never put 1 down here for January. And the reason for that is if I'm briefing anybody in a non-academic way, like let's say that what I want to do is do this forecast here. And I want to show people this chart because I need money. So let's say that Lauren is the chief executive and I'm in the brief and everybody's trying to get Lauren's money. And I'm trying to convince Lauren of what the sales are going to be in July and how they're going up every month. There's no way I'm going to show her a chart like this. I'm going to make it super easy for Lauren to look down here and see July and see how this direction is going. Just like a meme or a cartoon in a magazine or something. So the minute Lauren sees it, before I even say anything, she goes, no kidding. You're going to sell a ton of hot dogs in July. Here's the money. All right. The rest of you posers get out of the way. All right. So I would never show anybody a chart that looks like this. So I would go back and clean this up later. But for the purpose of this, same process. I'm going to figure out my slope. Always load those Y's in first. You're going to go to sleep saying that tonight. Y's in first, Y's in first, Y's in first. And then your X's, remember your X's are not that January, February, March. Your X's are going to be that right there. Okay. Intercept next, same. Y's in first. Oh, my microphone gets in the way. And then my X's. Boom. Okay. Anna Grace, what number am I going to use there for my X? So I have my M, I have my B. What number do you think I'm going to use there?
Mute was on, sorry.
It's okay.
I would say maybe the 0.9809.
Okay, we're headed in the right direction, but what we want is a number to signify that time period, just like these numbers up here. So it's kind of like a little puzzle. So it wouldn't be 5 because that would be May. And we don't want to do May, we want to do July. It wouldn't be June. So this May would correspond to 5.
Oh, I see.
See what I mean? So what do you think
Yeah.
it would be?
7.
Right. Now, I don't want anybody to get confused. In this model, our first time period was January, but that was coincidence. You know, in conventional numbering of months, January is the first month of the year. But let's say this was October. We had something like this. Our first time period was October, and then we had November, etc., December. We wouldn't put 10 here. We would put 1 there. Okay. Another example, we could have Monday, Tuesday, Wednesday, Thursday. Whatever our first time period is, that's going to be 1. Okay. So don't get tricked. I purposely set this up so that you have spacing. I want to know July. Don't get fooled and put July here and say that's the 5th time period. See what I mean? Because you need to account for that growth that's going to occur based on this growth right here. Okay. So finally, here's how we're going to put it all together. We have our value of X now, and we're just going to walk this thing left to right like we always do. So slope times X, which is 7, plus our intercept. So based on this, our projection says we're going to sell about 850 hot dogs in July. Okay. And again, if we wanted to show this on a graph, we would police this up to show that. All right. So the point of this is that time, we can use time as one of those two variables to identify relationships with. And then based on the strength of that relationship, either positive or negative, we can base assumptions, valid assumptions on that in order to do some regression. Now, very quickly, with any modeling, with any data, now that we're D3M warriors, we know that there's limitations of every kind of model. And we want to know what those limitations are so we don't get too carried away and do something that we shouldn't be doing. Misuse of the data, misuse of the model. So here's the deal. So in this case, we had this data right here. We had data for January through April. I'm just going to highlight that in a different color. Okay. Everything below it, we didn't have data for. This R value was based off of that data we had there. So we are making the assumption that this trend right here, is going to continue throughout May and June and July. Okay. That's not an invalid assumption. We aren't assuming the problem away. In my opinion, based on the strength of this correlation right here and the nature of what we're talking about hot dogs in the summer. Okay. Probably a pretty valid assumption. Now, where our model becomes more and more limited as time goes on. So if we forecast for August and we assume the same trend continues, our model, our assumptions start to get a little shakier. Okay. And let's just paint the extreme. Let's say that somebody goes, well, what are we going to look like in November? At that point, I would be hesitant to do anything, to do any kind of prediction with this model. All right. Because at this point, we're probably pushing it. Let's paint an even more extreme example. Let's say instead of hot dogs, this was fireworks. Well, we know that after 4th of July, that trend is probably going to reverse a little bit. So we probably don't want to use the same slope and intercept anymore past July. Okay, so we're always limited by the data. Sometimes we have to make assumptions on what the data tells us. And with regression, there's no hard and fast rule like beyond 3 months, you shouldn't go out any farther. But we know just from actually a general forecasting principle, the farther we go in the future, the more inaccurate our forecast is going to become. And at some point, it's going to become invalid. We're not doing weather forecasts. I don't deal with weather forecasts, but I can make the analogy. It is like weather forecasting. So weather forecasts, the validity and the reliability of the forecasts generally kind of are within 48 to 72 hours. I think 72 hours is even pushing it. Once we start talking 10 days from now, you might as well not even bother looking at it, especially around here in Pennsylvania. Okay. So it's the same kind of thing. Once we start pushing this out here, our model, our assumptions become weaker and weaker, and we kind of open ourselves to query. So let's say that I went in same scenario and I told Lauren, who owns the money and the decision, hey, I'm forecasting hot dogs for November. Lauren would probably throw me out of the room. She'd be like, number one, you're forecasting too far into the future. Number two, hot dogs are very much a seasonal item. And at the ballpark, they're even more seasonal. So I don't think that you can stretch that far into the future. So we probably wouldn't want to do that. Where do you need to kind of be solid on? Just kind of know that the farther I push this, the weaker the strength of my projections become in being able to back them up. Again, on exam situations, I'm going to make this pretty clear for you. I might ask you for some conceptual discussion, just a tiny little bit. Now, I can also do things like this. Go back to this green box real quick. And let's say any kind of variable, let's say I wanted to, actually, let's go to something like this. So let's say I didn't have, so I started with 200 and I kind of my range of my hot dog projection data or my hot dog actual data is between 200 to 622. I can feel pretty confident. So let's say that I have a demand for 420. I can feel very confident using this about my prediction for the amount of spinach salads that would go with that 420. And that's because I'm inside the actual data that I have. All right. I'm not necessarily going to be perfect, but my forecast error, the amount that I'm off on spinach salads, is probably going to be very, very low because I'm inside the data so I'm not projecting out, I'm actually projecting inward. And when I do that, the strength of my assumptions are actually very good. Okay. So that's where traditional regression people like to kind of stay in that nice safe box there. I think that you're never going to get anywhere in business if you don't push it a little bit. I mean, we all want to be shot callers. We just can't kind of go way, way out in the future. And that's just kind of silly and irresponsible. So that's another way we can use regression with time. And again, we can use regression to predict items that would go together and then items that wouldn't go together, and then maybe how things will change based on time and demand would change. So those are 3 ways that we looked at very quickly. And I know I'm over time. I apologize. Well, I don't need to show you where it is. The regression assignment is open on Canvas. Again, that's due 1 minute before midnight on Sunday. But if you have the time this evening, again, you probably have tons of things you need to do. And so make the choice that's best for you. But if you have time, I would encourage you to crack open that assignment and just start kind of doing what you can. And you might find that you finish it tonight. And the reason I say that is because it's fresh in your mind and it'll make probably the most sense to you tonight, maybe more than it will tomorrow or the next day. But that's just a recommendation. You know what to do, what's best for you. Because we're over on time, I'm just going to give my usual sign off. If you have questions, you want to stick around, I will stick around as long as you want to. Otherwise, I will see you on Thursday. Have a great week in between. Thank you.